Okay, welcome. Here we are. Welcome to our 2030 hub. We are at the end of April, which is amazing to think that here we are in 2024, 2023, getting close to the end of the financial year, almost in 2024 starting. And it's just every session just seems to be getting better and better, and we've got more and more projects that people are discussing, more and more interesting topics. And today is going to be absolutely no different. So, Anthony, did you want to just say anything about Symphony 7? Thank you so much for hosting this, and then we'll get in and I'll introduce our wonderful our wonderful speaker, Stephan, and then we'll just kick off.
Yeah, 100%. Absolute pleasure. Thank you, Stephan, for joining today. And if I'm not mistaken, you were initially invited by Peter. Is that right, Pete?
Yeah, that was the initial connection, yes.
Okay, well, Peter, thanks for thinking to introduce Stephan. Stephan, I'm really looking forward to what you've got to share about sustainable agriculture and the mix of chemicals and non-chemicals and what it means for the sustainability of the soil, etc. If you're able to stay for 5 minutes at the end, I'll be super grateful, because I've got a patch of grass out the back here and I cannot get the grass to grow properly. I've got gaps everywhere. Clearly, I am an absolute novice. So I know you know a thing or two about what makes things grow versus not grow. Of course, at Symphony 7, our key interest is in not only connecting people so that we can support each other and each other's businesses, etc., but also, of course, making a difference in the world to humanity and to the planet in terms of sustainability. So it's a great privilege to have you here. And thank you for organizing things, Maurice. I know you're about 5,000 kilometers from where we are right now. But thank you for your diligence. And Vlad, as always, thank you for facilitating.
Well, it's going to be an exciting conversation today because Stephan was very recently, the lead, the president for one of the biggest companies in Australia that you've probably never heard of, except for that one time. We were just joking before we started with Stephan that the one time everyone heard about Incitec Pivot was when the world suddenly realized there's a urea shortage. The Russians, the Chinese, everybody's stopping production. What are we going to do? The trucks aren't going to run. AdBlue's not going to be manufactured. We're not going to have fertilizer. And suddenly everybody knows who Incitec Pivot is. And then, it's one of those interesting moments. But, Stephan has been, as the president of, Incitec Pivot Fertilizers, it was a really pivotal role. Prior to that, Stephan has traveled the world, worked in huge organizations from, irrigation companies through to seed protection, crop protection businesses right across Asia, in very long stint in China, 7 years I've got in my notes here. And so there's probably one of the few people who are extremely capable and knowledgeable in this space to have this conversation and lead the thinking and lead the discussion for us. And so we asked Stephan to really maybe talk a little bit about the things that drive him and what it is that are most critical in this sustainable agriculture space, and to really open up the floor for some conversation. So Stephan, we really appreciate you attending, you coming. We've got a lot of people who are going to be listening to this later that will want to probably have a talk and maybe reach out to you. And I know that Anthony and Maurice always, organize those sort of conversations. But please, if I can hand over to you, kick off our conversation, and let's have a really interesting discussion.
Sure, thanks, Vlad. Good morning, everybody. So my name is Stephan Titze. As I said, I recently retired as the president of Incitec Pivot, and I'm enjoying my time up here at the Gold Coast. And though I do plan to get involved in some companies and initiatives around sustainable agriculture, because I think there's a lot to be gained from that for society and also from a business perspective. And I think it's always interesting that the general public actually does not know that much about agriculture, even though they think they do. I think, and sustainable agriculture, by the way, has not just emerged when climate change happened. It has been existing for a very, very long time, as sustainability and productivity actually go hand in hand. Because if you're a farmer and you're trying to manage your farm, you need to manage your enterprise for the long-term sustainability. So you need good soil, your most important asset. You need to control your weeds and your pests and all that sort of thing. And you need to, of course, produce high-quality food or produce which you can sell. So from an economic perspective, what's really novel, I guess, in the last 5 years is the whole issue around carbon footprints, which has not just emerged in agriculture, but in every single industry all around the world. You know, frankly, I think if you go back 5 years or something like that, companies would have a corporate social responsibility report at the time. And it didn't really talk too much about carbon emissions whatsoever. But all of a sudden, with the event of greater focus around climate change and people wanting to address this climate change, all the supply chains, all the different companies, all the different service companies even need to really have a strategy and some knowledge around what they're going to do in order to manage their carbon footprint. A fascinating new area for everybody. And I guess, you know, you can have lots of opinions about climate change. There is no doubt that there is a warming going on. I come from Switzerland originally, and our glaciers have definitely retracted quite a lot. Now, there are people around who say, well, this is a natural phenomenon, but at the end of the day, there is an absolute opportunity in order for us to address this and reduce our footprint. And it has positive elements to it in general. And of course, a lot has to do with energy, but a lot has to do with lots of supply chains who are subject to climate, who create emissions when they do that. So there is really, it's a no-lose situation. It's only a win-win situation for everybody to move forward and try and address this in a way, but also that must make economical sense. And anyway, you'll see in a minute. What I've done for today is really to gather some data around emissions from agriculture, particularly in Australia. And then some of the ideas that people are talking about to reduce emissions going forward, which, you know, everybody across the agriculture industry and the food production industry, etc., is working on these things. And then I'll give you some example from my old fertilizer company on how we were thinking at the time. I was also the chairman of the Fertilizer Australia, the industry association. So actually, the presentation, some of the slides that I have in the background, which still have Incitec Pivot on it, were public slides which I've used beforehand in that presentation for Fertilizer Australia going forward, with some of the ideas on how you could address this. So
Stephan,
let's start.
Stephan,
yeah, sure.
Before you jump in, one thing. So first, I just want to just check, are you comfortable that, because we've got a pretty tight group today, can you see on your screen when you're presenting, can you see the raised hand? Can you see how on my picture there's a little raised hand? Did you see that?
I can see your picture, yes, absolutely.
Can you see I've got a little yellow hand poking up?
Yeah, I can see that, yes.
If you don't mind, because we tend to have a very interactive group, do you think maybe as you go through like a topic where you discuss, you know, say we're discussing the emissions, maybe just give people an opportunity to ask some questions instead of all at the end?
Sure, no problem
for us to do that?
No
because
problems.
we have, because the people, especially those who are here, but everyone always they burning questions, and sometimes things move on, and I know they may get answered, but sometimes people want to have that. So yeah, that'd be great. So if you look out for it, and if you don't notice it, don't stress. I might just call it out just so you know that somebody just wanted to ask a question. And I wanted to just double check. It's Stephan or Stefan. How do you say your name properly? I thought it was Stefan always.
I call myself Stephen, translated
Stephen.
to Australian.
Ah, Stephen. Okay. Whatever makes it out. What would you like to be called?
Stephen is fine.
Stephen is fine, and then there it is. Thank you so much, Stephen. Okay, let's go. Thank you so much. Thanks, man.
No worries. Okay, so maybe just to, because we have people on the call who are not necessarily involved in agriculture, maybe a couple of numbers. So actually 55% of Australia's land mass, which is 427 million hectares, is used for agriculture somehow or other. However, a large majority of that is actually grazing land, which is more inland in the dry areas of Australia. So, of course, along the coast where you have more rainfall, you have a lot of different crops produced. You have crops such as horticulture products. You have vineyards, as you well know. And as you go further inland, you start to have your broadacre, your cereal crops. And it all changes basically with the amount of rainfall and the different soils and the climate that's available. So Australia is a very diverse agricultural market in the first place. Agriculture exports account for 11.6% of Australian exports. And actually 72% of Australian produce is exported to other countries. So, when we were in COVID and everybody's worried that we don't have enough food, we were calming people down and saying, don't worry, actually most of Australian produce is being exported anyway. And of course, into growing Asian markets. The Asian middle class is one of the key customers, but it's all over the place as well. You'd be interested, for example, to know that when you're in Europe, if you're going to buy the green fuel, which has 10% ethanol in it, a lot of this is generated from Australian canola, which is exported all the way from Australia on ships into Europe and then turned into ethanol and used in fuel. Does it make sense or not? I'll leave it up to you. But this is so Australia has a lot of different export opportunities for agriculture. And the gross value of production is 93 billion in 2021-22. And it has grown from about 60 billion only 6-7 years earlier. So there's been rapid growth of Australian agriculture production. Has to do with price, but also has to do with volume at the same time. So as such, though, agriculture only contributes 2.4% of GDP and is responsible for about 2.5% of employment in agriculture. So it has great importance, but the numbers of people and what it generates is still relatively small compared to mining, of course, and compared to the own internal demand of the economy. So, but anyway, the key thing we're talking about here is, of course, the emissions. And the agriculture emissions in 2020 were estimated at 73 million tons, or about 15% of the total emissions in Australia. So it is significant, as you can see from that. And actually, there's a prediction that these emissions will increase first by another 6-7 million tons to around 80 million tons by 2030. And after that, there is a prediction these emissions will actually decline as technology starts to come in to reduce emissions. Now, this does not include fuel, which is used in agriculture, which adds something to it. It's not that massive, but you can see it's a significant contributor to overall emissions in Australian terms. Now, the sources of emissions are mostly methane and nitrous oxide. There is also CO2, of course, as you burn fuel. But if you actually look at it on the graph on the right-hand side, you can see that the enteric fermentation of sheep and cattle, particularly cattle, actually represents the largest amount of emissions. Now, cows fart. That's my wife always jokes about this, and surely it can't be that big, but the emissions are quite large. And Australia produces a lot of cattle, a lot of it which is also exported to other countries around the world.
Stephen, is enteric fermentation, that's farts?
That's exactly right.
Okay.
It creates methane gases. That's right. Well, it's farts. It creates methane gases. So
got it. Okay, thank you.
Now, the other thing is, of course, that in general, in soil and around manure, when it breaks down, it actually creates greenhouse gases. So when people are very happy about creating composts, okay, they also got to realize that they're actually creating a greenhouse gas thing at the same time. So that biological degradation or breakdown represents a significant amount as well. So it's about the combustion and the decay of living or dead biomass in general that creates those emissions. And one of the smaller parts, but of course one that we were working about, is from a fertilizer perspective, it's denitrification and the volatilization, which creates nitrous oxide, which is part of the emissions as well. You can see it's relatively small, but we're trying to address, of course, all the different elements of emissions in order to reduce the emissions in agriculture. And interesting, rice cultivation even shows up here because rice itself, because it is grown in water, does have significant amount of emissions going as well in Australia. Even though there's limited area, it's actually significant. Now, what's interesting is that over the last years, there were, of course, what emissions which they called from land clearing, which would have also actually not helped. But actually, that has gone negative now. So actually more is being planted than what is being cleared. So that's actually in Australia a very good trend. I guess if you probably look at the rainforest in Brazil, you would have quite a different trend in that as well. But there's actually been a positive thing. Now, if you are interested in more of this data, you have the Department of Agriculture, Fisheries and Forestry, where you can have a look at this. You have a Grattan Institute report towards net zero, which has a lot of this data in it. And you have the Department of Climate Change, Energy, the Environment and Water, where a lot of these sources are. So there's a lot more depth of information if you're interested on some of these different markets, okay, on some of these different emission sources, etc. That is there. But fundamentally, 15%, okay, and it goes from different agricultural sectors. And you can see here that the livestock production is the number one in there as far as creating emissions. Now, of
Stephen,
course,
can I ask you a quick question? Can we
sure,
ask this question back on that slide? So I hope you don't mind. And again, to the team, if you feel like you need to ask questions, just please raise your hand so we can just address any of those. When you're talking about decay of the biomass and living in dead organisms, like, so does this also take into consideration any of the, like the FOGO or the waste that, because it generates significant amount of methane? In fact, there are times where we've seen, people building over landfill where, the gases explode. Just wondering, is that considered that? Actually, is that something where we just keeping that to the side?
No, I think in the analysis that's created in this Grattan report, waste is treated separately. Actually, you will see that it goes through lots of different industries and what happens, but the overall waste is not treated in here.
That's interesting. Yeah, because FOGO, the more we look at it, the more we realize that we want to deal with it, but geez, the amount of emissions that it generates is quite extraordinary as well. So okay, wonderful. Thank you, Stephan. Steve.
No problem. Okay, now if you look at emission reduction ideas in the different industries in agriculture, well, the whole net zero target is supported by the National Farmers Federation, by Meat and Livestock, by lots of different companies as well. So everybody's basically, adopting this kind of strategy, or this challenge, how do we get towards reducing our emissions and actually becoming towards net zero, becoming climate neutral by 2050. Or as early as they can, of course, because it gives them an advantage. And of course, the earlier you can do it, the better. However, this is not so easy. Some of it can be, of course, reduction of the activities that lead to reduce the emissions. But some of it may also be to offset some of this. And there are a lot of offsetting ideas in agriculture as well, because you can actually put carbon back into the soil and you can put carbon back into plants. So if you create a forest, it has it'll be able to absorb carbon. And some of the companies that have been developing, like one of the company that I'm probably going to mention a couple of times is called Regenco. And what they are doing is signing up large agricultural pieces of land with very large producers and helping them to manage their properties differently, to grow some forest in the properties or grow some native vegetation in the properties in order to absorb carbon. And for that, they can then get carbon credits, ACCUs, as we call them. And, you know, an ACCU nowadays is about $40, something around that. And it can provide an income for some of these farmers with large land holdings, with these different projects which they are doing. Now, so here are some of the ideas. So one I mentioned already is revegetation. There's some very large opportunities in that space. I was on a call a year and a half ago when the previous government was still there. And I kind of like this idea that if some of the farmers can revegetate their land and absorb carbon, those credits can be actually acquired by companies who need them in order to balance themselves out. So the way I looked at it is that fundamentally society, if they want to help with this, someone needs to pay for it. You know, it cannot be the poor farmer who can pay for all of this to do. So someone needs to do this. And this ACCU system actually can help them to make the investments in order to do that. So I really kind of like this idea. Of course, it needs to be measured properly and audited properly and all that. And you've seen some discussions going on around that. And there's been a recent review by Mr. Chubb or Dr. Chubb, and it has established some pretty firm rules now on how these things are being measured. Anthony, please go ahead.
Thanks for that, Stephan. It's worth mentioning to you that Chris Gray, who's in the room today, has quite a clear vision about re-greening farmland, which many of the fossil fuel companies have bought in advance, knowing that they can then get involved in the carbon credit game. And a lot of those farms apparently are being neglected, and they've got infestations of animals which really shouldn't be there. And Chris's vision, I hope you don't mind me sharing, Chris. In fact, maybe if we have time towards the end, we can actually discuss it, because I think it's very directly linked to what you're talking about now, the option and the opportunity to collaborate and to use these areas for really productive use, but also for facilitating sustainability as opposed to some of the stuff that's going on now.
Yeah, no, look, we had a quick chat yesterday with Chris. So I understand where Chris is coming from. And actually, there is also some legislation which is in there that you can't just buy land and just leave it deteriorate into nothing, you know, because that's not good use of resources either. And, you know, just letting growing weeds is not an infestation of pests and all that in the middle of agricultural land. Is definitely not a good neighborly thing to do. So I think there needs to be quite an integrated approach into some of these areas in order to make sure that what we end up is actually is economically feasible, practical, and also protects the environment in the right way. I think this is basically what we're trying to say here. So, yeah. And look, I would say a lot of this is emerging in the last few years. And really, you know, we can't expect all things to be perfect right from the start. You know, I think the government has done quite a bit now to start to establish rules and all that. I guess, you know, the big accountancy firms are looking to develop methodologies how to audit all of this, to confirm what's actually going on, because there's significant amount of monies involved with these ACCUs. But I think Australia is reasonably in a good position to do that, and you know, we should be moving quickly, because what's happening at the other side of this is that some of Europe, particularly, I think you'll be familiar with that, Anthony, is considering a number of ways to rate different products when they come into Europe, based on how they actually affect the carbon footprint in the world. So if we're not careful and not prepared and haven't done the right thing, we might find ourselves in some difficult situations how to export products into some of these markets. Okay, so the second one I'm talking about is increasing soil carbon. And I'll get to this a little bit later when I talk about what we were doing in the fertilizer industry in Incitec Pivot. But you know, actually a good farmer will make sure that he has proper soil carbon in there anyway. And in order for him to do that, he needs to have the right amount of nitrogen in there as well. So a healthy living soil with lots of microbes, okay, because the carbon fundamentally feeds the microbes, is important in order to grow your crops, because it can then release the nutrients and help you to actually use the right amount of fertilizer and grow the best quality crops and have a healthy soil in there. So, Anthony, I'd be guessing maybe your problem could be related to your soil, or it could be relating to shade, or it could be relating to weeds and the grass, etc. But you know, a healthy soil is always going to be the beginning of everything with the right nutrition in it, and I think soil carbon is part of that. The tricky situation with soil carbon is, though, it is relatively difficult to measure soil carbon. So if you have a very poor soil, yes, you can improve your soil over a number of years, and maybe you can get some accuse from it. But you know, how are you going to deal with a farmer that already has a very good soil? Okay, so he didn't get the benefit from this. So it is a tricky area that's still being developed, I think, on how we're going to do that. But in general, there is a good economical case for farmers to improve their soil carbon in the first place. Okay, so I spent a little bit of time on the livestock industry, which frankly I'm not that familiar with it from my agriculture background, but I do have a few friends and connections, etc., who help me a bit with this. Methane reduction, you've seen, that's a very large issue. And definitely one thing that's being developed in Australia and being licensed around the world now is the feed additive based on seaweed, which has been shown to reduce methane reduction significantly. And I think this is an exciting area. Basically for the cattle, which is basically grain fed, okay, because this obviously does not apply to the cattle, the grazing cattle, which is a large amount of the Australian cattle who are grazing around, but to the feed area. So I think technologies are definitely available for that. The other thing that's being developed is vaccines, in order to try and help the cattle to make them, in a way, absorb things better. And the other one is, of course, breeding. Now, you will have different breeds of cattle that will have a more effective absorption of these products, and therefore will, I don't know, fart less or something like that, have a reduced methane output. So, you know, one of my friends, he's actually working on this, and he's developed, he's talking about really developing more heat-tolerant animals, because there's a link between the whole lifestyle and how they ruminate and how they absorb things and the feed efficiency. So, you know, there is definitely an area where you can work on types of cattle, breeding type of cattle, which is more efficient in that. You've got to imagine, if this was not really the key issue 5 years ago, probably it was different ways of breeding for cattle. But there seems to be a good link, potentially, to have cattle for better feed efficiency and also reducing methane gas emissions at the same time. The other area is, of course, manure in the feedlots, which is a big issue. And I'm certainly aware of a number of things that people have done in order to create materials which absorb, actually, some of the urine. The urine is actually a major source in some of these feedlots, and a lot of it actually goes up in the air. It volatilizes, but it's actually potentially very valuable fertilizer with lots of nitrogen in it. So there are ways of potentially collecting that and ensuring that can be reused again in agriculture areas. Now, you can imagine if you remember the size of these emissions, obviously there's lots of people looking at different ways on how to do this. So I think exciting potential technology opportunities in this, and a lot of people will be working on it in the next few years. So when it comes to fertilizers, which is the other part, you have a lot of different initiatives, and the key one I'll talk about some of the things that we try to do at Incitec Pivot Fertilizers and the industry in general. Recycling materials in order to turn them into fertilizer is obviously one way how you'd be able to do that. Fertilizer is generally made from gas and rock mixed together. And so if you can recycle some of these products, you create a more sustainable plant nutrition system. The other one which comes up here is the volatilization of nitrous oxide. And there's denitrification inhibitors available. So Melbourne University, Incitec Pivot together with Melbourne University actually have an Australian research hub, create smart fertilizers, where they're fundamentally coated and they don't release, they don't denitrify, and the plant, all it is available to the plants. So and this is really one of the ways how you can reduce emissions, but also improve the efficiency of fertilizers in general. And interesting enough, my previous company, Netafim, have actually developed a methodology to grow rice with drip irrigation. So you don't flood the fields and create these anaerobic conditions for fermentation, but you actually have drip tubes, which you can collect again afterwards, where it only gives this right amount of water to the plants and nutrients at the same time. Now, this is relatively expensive on a per hectare basis. However, in maybe markets like Japan, etc., there would be possibility to apply this. And if governments really want to be serious in some of these big rice growing areas, they could actually incentivize people to do this and could have a massive impact on emissions. I do remember hearing a few years ago, it's maybe a throwaway line, I can't verify this, but Italy alone grows a few 100,000 hectares of rice in the north of Italy. If they turned this into drip irrigation, they would be able to avoid as much as a lot of their cars on the roads from pollution of fuel vehicles. So, you know, there are real significant opportunities in agriculture with technology to actually make things, to change things and do something quite different.
Wow. And Stephan, I imagine that would count. There's a lot of countries that produce huge amounts of rice.
Absolutely. India, China. India, China are the leaders, and then Indonesia. But of course, you also got Thailand and Vietnam as well in those areas. But, you know, a lot of this rice is it's grown by smallholders, relatively small plots. And it would be quite a challenge to implement something like that in there. But you know, it all depends. I don't think this will be possible without government support. And somehow, because again, it comes to the same thing. You cannot expect the farmer to bear the cost of all these things by themselves, because he will not be able to sell his produce to the consumers. There must be a way to somehow or rather create the change from an economical perspective and social perspective in a feasible way. Not that simple. But solutions are available in many things, you know, and as you know, there are many simple things that you could do in order to reduce energy consumption in Australia. So have a look at some of our houses, how they're insulated, I should say, sorry.
Insulated,
so,
yeah, that's right.
Double glazing, you know, who's got double glazing? You know, maybe your new houses will have double glazing, really good insulation, you know. Our house here, unfortunately, I have to say, we have to use air conditioning in summertime. You know, I go to Switzerland. Some of my friends, they have a house which is when it's 35 degrees, they let the things down, and they're able to contain the temperature in summertime still around 20-something degrees in the house. It's built very differently, and so there is a lot of structural things we can do to reduce energy use as well. and address some of the whole greenhouse gas emissions in that way as well. So
that's so true, Stephen. That is really true. I think one of the things that we've learned also from working with people like Ahmed, who's on the call, and James McGregor, is that when you approach the problem from the bigger picture, like, what are all of the emission pieces, or what are all of the leaky bits, and who really is going to pay for it? So where do you look at the supply chain, or where do you look at the output? Looking at it from a bigger picture and going, okay, actually, as a whole, we might build this. If we take the example of the house, we'll use the double glazing, but all of the frames leak energy because they're not properly sealed. So you've got this wonderful glass, or you've got this beautiful process, with with the animals, livestock, but this other piece is just completely missed. So therefore, it's balanced. So almost fighting against each other. So I think there's something about taking a process overall and saying, okay, as a whole, what are the gaps, and can we change the whole process? That can be really difficult, and it does need to be driven by industry together. I think that's an important point.
Sure. Someone's got their hand up.
Julie.
Hi, Stephan. Yeah. Hi, Vlad,
iPad.
and hi, everybody.
Julie on the
off
iPad.
The tram. Yeah, I've just got off the tram. So I just wanted to share one of my board directorships is Greening Australia, and we operate in the restoration of land business with landowners across Australia, as well as government and miners and all sorts. And we have some significant goals, like 330,000 hectares that we want to revegetate by 2030. And we operate in this sort of market-based economy, which for a not-for-profit has been quite challenging. However, there is a great need on the demand side, right, for offsets, be it ACCUs or be it potentially the new biodiversity assets that's going to be created with changes in legislation. And our biggest issue, and it's just to put it out there, is about the supply side of the equation. So how do we entice landowners, miners, to actually give us a funnel of supply so that we can fulfill the 330,000 hectare goal? So anyway, look, I don't know the answer. If I did, I wouldn't, I'd know a lot more than I do now. But yeah, maybe thought for discussion later.
Okay. Well, maybe Julie, I'll just throw this in. Maybe Chris can talk about this a little bit. So, I believe there is a number of companies, mining companies, etc., acquiring land, and they're not doing much with it. So maybe you can talk to them about this. Yes. Maybe I can talk. Maybe I can talk quickly. I can talk about a company that I'm familiar with, and it's a company called Region Co. I don't know if you've heard about them. So they're signing up basically big grazing partners, and they don't do anything below 200,000 hectares, by the way. So in order to make these projects feasible, and then you take about 30% of this, and you develop a methodology on how to develop infrastructure through water, through fencing, through in order to reduce the intensity and then grow the crops on it. Grow the forests on it. Yeah. I think that's already quite well advanced in that respect. If you don't know them, Julie, maybe you can have a chat with them.
Yeah, no. Look, I'm in Greening Australia's offices at the moment, so I'll ask the CEO in a minute about them. So thank you. But I think we're in a similar marketplace, but that doesn't matter because the problem and what's ahead of us is so enormous. We need players across the whole, of Australia to make an impact. So anyway, it's really interesting. Thank you, Stephan. No worries.
By the way, I'll tell you what I think your largest challenge is. You have insufficient supply of seeds for native vegetation.
Okay, so, I can talk to you about that later.
So there is an opportunity to create a native seed. Native seed companies is definitely something that would be. But to do that also, requires a lot of expertise. It requires scale, and a lot of native seeds, as you probably know, is licensed. So it's also not an easy thing.
We've actually got a subdivision or a company that's involved in SPAs, as we call them, which is seed production areas, not the other kind of SPAs. And that's a national initiative that we have.
Yeah, look, I mean, I would say, I don't know if maybe some of the large global seed companies might be interested to help with this, you know, and even make a significant investment into this, because they would have the expertise on the processes and how to do that. I used to work for Syngenta, and so we did a lot of seeds, particularly vegetable seeds and all that. So it's not so easy. You need to grow it in very specific environments to avoid disease and all that. So, you know, you're growing a living product. It's never easy to grow a living product. So,
absolutely, yeah. Anyway, look, I don't want to hold you up.
No worries. Okay, so maybe I will take you now. I really talked to you a little about my past thing. So Incitec Pivot, for those of you who don't know, it's actually the second largest explosives company in the world and the largest fertilizer company here in Australia.
Sorry, Stephan. Before we move to the next one, I just see Hamed has his hand raised as well.
Sorry about that.
No, it's all good.
No, thank you. I just wanted to mention something quickly, which I thought would be sort of relevant to all this discussion about the projects that we are doing now or involved with. It's somehow related to this, could be interesting for anyone's involved. We are actually working with one company and developing an equipment or machinery for measuring soil carbon on the site. So that's a fully autonomous equipment or machines that goes to the land, and they can collect the sample, measure the carbon, and send the data to the clouds. And the aim is to have, you know, at least somewhere close to 60 sampling in a day. They already have some clients that they're asking for 30,000 sampling help for that. So that is a project that we are working on, and hopefully this year that would be finalized regarding the testing of it, at least.
Well, you might be interested in my next few slides, because Incitec Pivot actually does run the biggest soil testing lab in Australia. So maybe there is
one
something.
Important things on this project is that it does the testing on site. So you don't need to take sample and take it to the lab to testing. It will do the tests on the land. Anyway,
sure. And you're making sure that you're digging deep, like half a meter or something like that.
900 centimeters.
Very good, very good. I'm sure there could be a collaboration that you could have with them, so that actually could work quite well. So okay. So anyway, look, maybe I start off by saying this. Okay, so a lot of companies and Incitec Pivot have been in the forefront to develop a pathway towards net zero by 2050, and you know, it involves, of course, efficiency. It involves abatement in their factories. It involves solar energy going forward and things like that. And one very important piece is, of course, green ammonia. So, as you know, they have a project together with Twiggy Forrest in Gibson Island in Queensland, how to produce green ammonia from hydrogen. So you can read about that project in both Forest Future Industries or in the Incitec Pivot one. And of course, that would then mean that your input, as opposed to being gas, you split the water molecule, okay, and using fundamentally renewable energy. So you will have real green ammonia. And I think this is one of the important projects going forward in agriculture, because if you can actually produce some of the nitrogen fertilizers from green ammonia, you obviously have already eliminated a lot of the emissions, particularly the emissions coming from the scope 1 and scope 2 emissions. So this is one of their key plans. But what you see on the right-hand side is that the largest, and I think this may be the same for a number of companies who are in the manufacturing area, the largest footprint is fundamentally your scope 3 emissions, which are the emissions generated by your customers when they use your product. And so the next few things I'm going to talk about is really a bit about that, on how ideas, how we were thinking of reducing the scope 3 emission footprint. So, I'll start with this. And I think I'll use the example of my house a little bit on this as well, because it's all very similar. So we always said, use only what is needed. This is one of the very important ways of actually reducing emissions, or using less of what you need, So Incitec Pivot runs this laboratory called Nutrient Advantage, several 100,000 samples every year. Basically what it means for the farmer is you send in your sample, it'll analyze your soil, you can have different degrees of analysis, and you tell what crop you want to grow. It's like going to the doctor and having a blood test, okay? And it'll then make you a recommendation, what nutrition product should you be using in order to replace the nutrients in your soil. So your soil remains the same at the end of the day because your crop removes nutrients, okay? So fertilizer business is not that unsophisticated, I would like to say. Most of the large farmers use soil testing, first of all, and actually then work out what they need to replace. So then don't just blindly put fertilizer onto the ground. Use only what is needed. If you take the analogy for your house, okay, well, your air conditioning system has ducts, okay? Well, I turn it on, but actually I can turn off a number of the ducts. There's a little thing you can screw on the top, stop the air conditioning going into all the rooms that you actually don't need it. It's a relatively simple thing. If every person in Australia did that, I didn't really know how you do that, and someone explained to me that all the air goes throughout the house. You close a few of those ducts, and it only comes to the rooms that you need it. Well, you only use what is actually required. So there you go. I make my contribution to energy savings already. The other thing is, often what they also do, they have a program which is relatively simple decision support system, which then allows you just to plug in this information, and you press a button and it tells you what products you're going to need in order to do that. So to make it convenient for people to make decisions about some of these things was one of the other ways how we were doing this. And I think it actually makes perfect sense. It's, you can have it on your mobile phone. So you have quite a lot of information about what you should be using, or use only what is actually needed. Now, the other thing is, use it only where it is needed. So if you go to agriculture and you go onto a field, you can take a sample from one paddock, which a lot of people do it that way, and they draw a conclusion about what is in the rest of the paddock. Well, actually, technology has moved on significantly, and we can be more sophisticated because across the variation of a field, there is different requirements for nutrients. Some of it will need nothing. Some of it will need a lot because of the variability of it. So we worked with a company called Precision Agriculture, who use a little four-wheel drive tractors, who takes lots of samples, maps a farmer's property then, and has actually a software which connects directly to the tractors. So the tractor doesn't put out the same amount of fertilizer everywhere. It puts less here, less there, etc., according to the pattern from this. So we think definitely this is kind of the future again. You use less, you reduce emissions, because you're putting the stuff where it is actually required. And a lot of the world is now about sensors, about all these sort of things, in order to do this. Now, I guess my example from the air conditioning still kind of applies, even though it's not that sophisticated. But the other thing I would use is in this is that when you think about your own house, you can buy for $35 a device from Bunnings, which you can plug in between any fridge or a TV or whatever you have, you plug it in, and it'll actually tell you how much energy that item uses. Now, that gives you a way of actually understanding what your energy is and where it is needed and how you may be able to save on your energy, you know. These tools are available, and more industries need to think about this, on how to actually, this is one of the ways how to improve and reduce things, is by actually using devices and also analyzing what is needed and then putting it where it belongs and not where it doesn't belong. There's a lot of waste going on in general, but in agriculture definitely as well. This is one area that can be improved. Now, the other one is use it and don't lose it. You know, maybe the air conditioning example is one, you just don't keep your windows open when you do air conditioning, because it doesn't make any sense. But in the fertilizer space, basically, fertilizer, when water gets onto it and during different climatic conditions, it can denitrify and volatilize. So how do we stop that? Well, there are actual products available which are coating defertilizers and stop them from going through this process, and therefore releasing in a slower period of time and only under the right conditions. And so they're called nitrogen inhibitors, which stop this whole thing. So if you treat significant amounts of the nitrogen in Australia with these products, you will absolutely be able to reduce your emissions again, your losses from fertilizers. So this is using technology to reduce losses here. Okay, Vlad?
Stephen, just a quick one. We've seen some really interesting projects in this space, particularly, you know, where there's the coating, so it's slow release, the coatings and so forth. And I noticed that I think it's EU, when they look at some of these products, if they use any kind of plastics in those coatings, they're just not allowed because they put in microplastics. And so have you had some experience, have you seen some products where they're using non-microplastics, so they're using, you know, natural materials like bug skins and so forth, or whatever it might be? What's your view on that? Just interesting to know.
Yeah, look, we decided at the time not to develop the plastic coated products as well, because I think there is a trend that you don't want to put plastic into the environment, I think. So the EU is definitely ruling this out. The EU has also, by the way, in Germany, stipulated that people must use these are chemical inhibitors. Chemicals break down into whatever afterwards in order to stop this volatilization. So Germany already has legislated, and I think in New Zealand in some parts as well, that you cannot apply urea without these inhibitors because it reduces that. So in the future, I think you're going to find further maybe biological type of products that can do that. But you know, chemicals, I would say, chemicals as such are not bad. Okay, it just depends how they break down and how they all work, and of course they need to be tested for the environmental impact. But I think this is a definite growing area, how you can avoid this denitrification and volatilization going forward.
Awesome.
Okay, the other one we talked about is recycling. Of course, you're talking about waste streams. You know, there is plenty of waste streams around. There's a lot of companies trying to use waste streams in order to make fertilizer and bring them back. Very challenging from a logistics perspective. The costs of transport are high. A lot of waste does not have consistent nutrients in it. A lot of waste has low nutrient values in it. We looked at chicken waste, which is quite a large waste stream and has the highest possible nutrients in it. And so we developed actually some products which are perfectly the same, but they're basically 40% recycled materials. So this technology is available, and I'm sure this will grow in the future as people need to use up these things. What's not... some of the challenges is, for some of these investments is because this whole carbon and emission area is emerging, okay? It's actually, if you have a very good product that delivers some of these benefits, it needs to be recognized in order to get accused. So you need some investment in order to make sure that you can apply to the government, to the energy regulator, in order to get your benefits from it, or the accus for it. So I think, and the other challenge here is scale. You know, a lot of people do this in small scale, but really, if you want to make significant difference, you need to basically do in a scale business. Okay, and of course, okay, we talked already about green ammonia, and green ammonia will, of course, you will cut the emissions for making things very substantially, and so but that requires, again, large investments, as you know. So I think this area will grow in the future, and significant investment will be required. And I think there will be requirements also potentially for the government to help with some of this transition. This is one of the key areas for energy transition going forward. Of course, we have solar, we have wind behind all of this, but this is how you split the water molecule in a different way, and it requires significant amounts of energy.
Stephan, could you possibly give us just a 30-second helicopter view as to how green ammonia works? Like, I know you've just suggested it's a chemical process of splitting water. I know Jan Hesner of BASF has had an interest in this area for a while.
Yeah, let me try and simplify it from memory. But basically, you know, so we use, fundamentally what you're doing is you're taking water and you're splitting it into hydrogen and into oxygen. So the oxygen, obviously, you can release it as a gas. There's no problem with that. And of course, the energy you use renewable energy somehow. So you need to build a solar farm or something like that in order to feed that into the grid. And then you take the energy out and you go through a process of called electrolysis in order to separate the molecules. So that is the first step. So you then have a hydrogen molecule. Now, the hydrogen molecule is then combined with the air, okay, where you have nitrogen in the air, and that's how you create your NH3 here. So if you look at this, you can see here, you know, you got your electrolysis, gives you the water, you do the air separation, you get your N2, and you end up with NH3. Now, what happens is, of course, this is a product that can be used in lots of different chemical reactions, you know, chemical inputs in a chain, and it'll become green because it has not been produced from gas out of the ground. So there's no CO2 produced in this process. That's fundamentally the difference. You know, so if you take gas, etc., and you do all of that to create ammonia, you will end up with CO2 as an output, which adds greenhouse gases. This fundamentally has O2 and doesn't use that. So, and it becomes a feedstock for lots of different chemical processes around the world. You can probably Google it very simply. I think you will find that there'll be a chemical diagram showing the difference between the two, but basically it is about that. You're splitting the water molecule and you're not creating any CO2 with it.
Stephan, isn't it very volatile? Sorry, Julie here. Isn't it volatile?
Hydrogen is very volatile, absolutely. That's why you need to contain it, and then you combine it, and then you end up with NH3 ammonia, and then that is a precursor to lots of different things. But it has not been produced from gas that you're taking out of the soil, and no CO2 has been produced from that, you know, as an emission.
Stephan, I'm interested did Incitec look at using like biomethane rather than going down electrolyzers and that path for hydrogen production, just using renewable sources of methane to plug into the existing process? And if you did, why is the shift to electrolysis to hydrogen instead of just using biomethane as a substitute?
First of all, don't know, okay, but maybe they have in the past, maybe they found it. I don't know, to be honest, but no, I'm not aware that we have used this biomethane. I know in Europe, some of the mixed farming operations would use biomethane, and try and create it back in the system, for example, using it in their greenhouses and things like that. I know there is talk about the feedlots using the methane in order to burn it and create energy from it, etc. That is definitely on the cards. But not. This is, you know, this is large scale we supply large scale agriculture or explosives, and I'm not sure that you can. I'm not sure about the logistics of it. You know, if you had to go to lots of different places to collect this kind of material, how would you get it back into a scale, into a manufacturing plant? I think maybe there's a structural challenge, but you know, you've just exhausted my knowledge on that, James.
Yeah, no, I was just curious because at the moment you use natural gas to produce the hydrogen. So I did a lot of work when I was at CSIRO in steam methane reforming of natural gas to reduce CO2 emissions. So I sort of know this space well. And I know just in farm, if you just look at farm trash in New South Wales, if you were to use anaerobic digesters to convert existing farm trash, you could produce, I think we worked out 106% of New South Wales total gas demand, which includes all the production facilities and those sorts of things. So I'm just curious as to why everyone seems to be going down this pathway of, because the problem with hydrogen is where you're going to get all the water from, right? Because you're competing for other freshwater sources as well to produce hydrogen. So I'm just curious as for, you know, companies like Incitec, why that option seems to never be on the table.
Yeah, I can't answer your question, but I think the only thing I suspect, James, it's that decentralization, it's the small little areas, and then I guess for a farmer, I guess the hurdle might be the investment and also the expertise how to run something like that. You know, I'm not sure that it would be that easy for someone just to install one of those plants on their farms. First of all, maybe it's not big enough to justify the investment, and second, how do you run it? This is maybe another challenge. Yeah. There's lots of technologies that seem, you know, at small scale work fantastically well, but how do you apply them in a practical way? I'm not sure many farmers are really kind of, you know, geared up to build a kind of a factory, which almost like a factory with gas under pressure, etc., like that. I think maybe they would find that quite challenging. Ahmed, you've got your hand up.
Can I ask one question? Yes, thank you. I just wanted to make sure that my understanding is correct, because for this process, you need a purified water. So I think the quality of water is somehow affect this, and you will end up some byproduct of whatever else is in the water based on what you're using. Is that produce any limitation or problem in terms of where you want to have this plant and what you're going to do with that, or no, that's not?
Well, not that I'm aware that was a problem with water, to be honest. I presume that you can get it. I mean, the feasibility study is continuing, and I guess, you know, I think the big issue is around how much you're going to produce it for, and where are the markets, who's going to pay for that? Because, you know, as you start, you can imagine you don't have the critical mass yet. So, but someone needs to make a start, I think.
Yeah.
Jan, did you want to comment?
Hamid, if you want to talk about water qualities for electrolysis, I can share some things, because definitely that's a big topic for our process engineers at BASF, and where every project is literally different, because us normal people don't appreciate how different water is around the world, and what you can or need to do to purify it so the electrolyzer is not adversely affected. Basically, you know, you have to get the purities out, you have to get the salts out, etc. But there is a lot of effort actually being put into tweaking the electrolyzer technology so it is more flexible and can you know, ideally literally use seawater.
That's the ideal. Yeah.
But we're not there yet, and we're certainly not there, you know, to have that at scale. But I know there are clever inventions from various parts of the world, and I know we have a unit that specifically focuses on that as well, and works with some companies who are playing in that field. But right now, every single green hydrogen project is individual, because of the water that is being used in the process. Mind-boggling, really, learn how different water is and how it needs to be processed first. Yeah.
Well, Jan, if we could use seawater, you can see in the picture, that'd be the easiest way, but I'm not sure what's assumed here on the water side of things.
Well, the trouble is even seawater is different all around the world. You know, you have different levels of salinity, and you have different things floating in the seawater that have to be filtered out and so forth. So yeah.
One thing I can say that on Gibson Island, I know on Gibson Island, the plant is actually directly next to the water treatment plant run there. So I guess hopefully that'll be an advantage to create the water quality that's required for the hydrolysis. So.
Yeah, that's actually a project that we're involved in. So I know from the various engineering companies who are talking to us.
There you go. You know more than me, Jan.
All right.
Thank you. Now the last one, the technologies. I guess we talk a little bit about these technologies already. You know, we believe there's going to be a lot of interesting advancement driven by this need. So one of the things that we were doing at Incitec Pivot with the assistance of the government, Melbourne University, is actually an Australian Research Council hub for smart fertilizers. It's $11 million over a number of years. And we're trying to develop the next generation of inhibitors who are more efficient and really address some of these things. And I think so that some of the concept there are that we actually can coat a fertilizer with a coating which reacts to the enzymes of the plants. So therefore, the fertilizer will not fundamentally be available unless the plant's roots release an enzyme, which then starts to break down the coat and release the products. Actually, BASF is always involved in this kind of fertilizer technologies as well. And I met with some of the BS guys last year, actually. But this is a project in Australia. And I think it builds on some pharmaceutical technology. Some of the products that you take as a tablet, they don't actually start to work until they get in your stomach and they get released or wherever it is released. And so I think this is the kind of ideas that could further help to reduce some of the emission problems. So, you can imagine you put a fertilizer there. If it doesn't rain, nothing happens. There's no plants there. It just sits there. It doesn't actually break down. But when the plants come, an enzyme is released, they recognize it, and off we go. We get the nutrition. So a lot of very sophisticated ways, again, to really change the game with regards to how you would actually manage some of the emissions. So really, that's kind of that was my last thing. So, honestly, I'm not sure that I can give you a very broad point of view on all of this. This is really some examples that I'm aware of, a bit about agriculture and what's happening in emissions, which a lot of you seem to be familiar with that already, and some of the things that we were doing when I was working at an Incitec Pivot. And also this presentation came from a Fertilizer Australia meeting where I was the president. And this was basically trying to inspire ideas from the industry on how to move forward and become more sustainable, particularly in the face of this climate change and emission challenges. And it's quite incredible. I talked to a number of my friends, etc., who are involved in some of these different businesses, and some of the concepts and business models which are developing are quite incredible. And I'm sure human ingenuity will come up with ways to find lots of different solutions and create lots of interesting businesses. Though I think it's not going to happen in the next 5 minutes. I think we need to be also patient to make sure that we do things that work properly, scientifically proven, and we also need to support always of governments and lots of different partners in order to move some of these things forward in many companies. So.
Thank you so much, Stephen. I was just going to say that when you're talking about that, the research in the industry, the ARC research hubs so important. They are really, they help industry push with the support of the research, in the universities. That ARC Research Hub for fertilizer, when did that start? That's been going for a little while?
3 years ago, I think it started. Maybe it's 1.5 years ago, and it has a target to reduce to increase nitrogen use efficiency by 20%. To develop some products, and it has got 5 or 6 different streams that are working. These are all PhDs who are working on some of these things together with industry in order to deliver some of these technologies. So.
And that's Melbourne University run ARC? That's
Melbourne University, yeah.
Fantastic. Oh, that's awesome. I had only one other question that I just sort of had in my general notes that I want to ask with the conversation. I think we sort of alluded to it at the beginning with the global urea issues. Where does urea fit into this conversation? I just was hoping you might be able to touch on that just for everybody's knowledge.
Well, urea is it's actually not it's the most used source of nitrogen around the world, basically. It has the highest, it's one of the products with the highest concentration of nitrogen. So it is produced from gas. It's produced in the Middle East. It's produced in China. It's produced in a number of places. It was produced in Australia, not until last year at Gibson Island, as you know. And there is just a new project announced in Western Australia, urea in I think 2027 or something, Perdaman. So urea is kind of, nitrogen at the end of the day. There's a lot of statistics you can look at. The population growth and nitrogen use are pretty well matching each other, kind of thing. So it is nitrogen is really, and it's the pure form of nitrogen. You often use it at the beginning of the planting, but more often you actually use it to pop up the crops. So if you go to Bunnings, you will find there is a lot of products that have nitrogen in it, and probably not the pure forms. You get more of a mixture of things, but urea is the #1 form of nitrogen all around the world. So and produce some in Russia as well, by the way. So which ran into some problems, and that's probably where you realize some of the prices of urea went up significantly last year.
Yep, no, I appreciate that. Thank you. Questions? Just put it out to the group. Any comments or questions? I think we came to, that was very, very thorough, and actually provided us with lots of insights, Stephen. So really appreciate that. I guess I was going to say this is the moment where things are shifting quite significantly. And I see Julie's hand up. I'll just come to you in 1 second. We've seen a number of organizations who've come through this group over the last couple of years that have focused on soil testing. So when we were talking about the trees and the like, we see organizations around the green production. I know production of ammonia has been a big conversation, but the use of urea and the need for natural gas and its production and so forth. So I think there's broad, and I really love that you've had that broad cross section. So I think for a lot of people who will look back and watch this video, I think they're going to probably go back over a couple of times and just realize just that this topic is not single form. There's a waste component that you touched on as well, which we see is a huge contributor in the agriculture space, especially using that waste in fertilizer. We see the FOGO process and so forth. So I think there's probably going to be a lot of further conversations coming up, even more than what we had now. So I really appreciate you taking that time to do a really broad approach. We really appreciate that, Stephen. Julie, your hand is up.
Yeah, look, thank you, Steve. I've got a lot of questions. I don't know where to start, but there's just one perhaps, which is about farmers and their acceptance of sustainability principles. And bodies like the National Farmers Federation, and there's quite a lot of carbon based agricultural farming associations as well. So just like that whole movement, in terms of change, you know, where are we at? I don't know if you can answer that, but
well, usually
big question.
Well, I would say this. I guess 5 years ago this was not a topic, so that's the first point. Second, I think is we then saw some farmers getting some accuse, if you remember that, the Microsoft case, you know. We don't saw quite a lot of discussion about, you know, what's the reality about it, what about the science behind it, how do you measure it, how do you make it reliable? And I think that's kind of where we are at the moment. I think we are definitely in a stage where I think the government did come out earlier this year after the job review to kind of on the revegetation, and a couple of those projects to come out with a methodology, which I think can be recognized. So, and I think that triggers further activities for people to think about how they do this. But I don't think it's a very easy area to understand for people and what to do about it. So I think we're kind of emerging, I think, from all of in an emerging way, I think, on this. Because it's the practicality of it. What am I going to do? So if I'm a farmer, I'm going to say, so well, what does all of this mean? You know what? And I think that's where you know, companies like, certainly I talked to a company called Region Co, and I think they are kind of dealing with some of the larger farmers and helping to develop a methodology which is scientifically and verified and, you know, and measurable. I think this is where one of some of the challenges are, I think, is how do you actually measure it and prove it? Because in a few years' time, someone's going to come and say, well, sorry, we'd like to audit you now. How did you achieve these kind of things, you know?
They already are, though, because to enter into the ACU market, it's very rigid in terms of, you know, what you do, how you measure it. I mean, there's been that Chubb review recently where they sort of interrogated, is it working? And I mean, it can be improved, but that whole measurement piece is vital to the ACU market working. Plus, there's also a biodiversity stream if the legislation goes through, which will add, that will what we call stack, so it will have the carbon and the biodiversity on top, which will produce an even bigger income stream. And one of the things that, you know, Greening believe in is that the capital markets or the market-based economies will drive the change, because we're talking money, right? And everyone understands money is a bit of a driver. So if you drive those things in that direction, it doesn't mean to say by any means that agricultural land would be used to plant trees, but it supplements the agricultural input and produces a better carbon outcome for soil and also biodiversity to connect properties one to the other. So there are corridors along usually creeks. So, you know, the potential is there in terms of market indicators coming up. And I think, you know, Australia is pretty innovative when it comes to these, you know, money talks, you know.
Well, Australia is probably, in my view, the most innovative country in larger scale agriculture. I think Israel is pretty damn good as well. But you know, a lot of it is driven by the need and by the opportunity. And I think Australian farmers will jump at that. Okay, I think they are adopters of all these kind of things. So if you would like to, do you know a guy called Robert Poole? No?
No.
Well, Robert works for KPMG, and him and his team have done quite a lot of work on this biodiversity and those sort of things in a previous time. So if you have not met him, I think you should. I'd like to connect you. He has a lot of knowledge. He used to be the CEO of Murray Goulburn, I think, or something like that. So he knows a lot about these ag. He's a farmer himself, actually, but he works for KPMG, and they do some pretty good work.
What's your surname, Stephan?
Pool. Yeah. Okay. Oh no, that would be good.
Yeah. So
Murray Goulburn is another story.
Yeah, well, that's a long time ago. But what I'm just trying to say, he's been working for a number of years now, and I know, for example, one of his team went to Woolworth and is there as a sustainability person now, and so there. By the way, the whole thing, the expertise in all of this is also just emerging. Okay, so let's be realistic here. Okay, you cannot just go out
right.
and hire someone to say, okay, now please come and help me to develop how this is going to work. I talked to the Region Co guy, they develop a methodology, they have people, they have scientists, but it's all emerging kind of industry, very interesting in that respect. I think that for the government to confirm fundamentally the rules and the settings and the measurements and all that, this is already a very important step. And then I think you will find the people who can verify it, and then we need the people who can consult on this and explain to people what do I actually do. And I think that's where a lot of the farmers are probably at. Who am I going to trust to work with, and what's the plan, and who understands those plans? We're talking. I remember a Region Co minimum area where they do it is 200,000 hectares. Okay, so if you don't have 200,000 hectares, because there is a size scale bit to this as well. So fascinating. And I do think though this revegetation thing makes a lot of sense. But I think there is fundamentally two principles. So one is we can reduce emissions, and there's lots of technologies around reductions. And the second thing is we can then we can do the offsets. Okay, so we do something which offsets it, and it's a little tricky because it needs to be real. There needs to be something real in there that's really helpful. Because I remember the case, an organic fertilizer company created credits which were then adopted by a UK steel plant. So the UK steel plant keeps doing exactly what they're doing. The organic fertilizer company that keeps doing exactly what they're doing, but somehow they become now net zero. That to me is not really the intent of the whole.
That's smokes and mirrors. That's why the reporting mechanism for ESG reporting, which is another thing that's coming out for ASX listed companies in particular, is so important, because that actually puts it on, in annual reports, what those companies are doing in this area. And those that aren't doing it will get a backlash because they're smokes and mirrors. So you have to have an active reduction in CO2 in your scope 1s and 2s, let alone 3s. And then, I mean, this is only supposed to be an offset at the end of all of that.
Yeah, no, absolutely. And, I think the opportunities for farmer is definitely there, because how else there is not, you can put, let's put it this way, you can put carbon into how many things? If you want to absorb carbon, it's plants, it's the soil. To a lesser degree, I would say it's the soil, but it is also possible into the soil. And it's the sea. You can grow coral if you want. That's also very helpful. So it provides an opportunity, I guess, for an additional income stream. And I guess where it is to me, to a certain degree, is that the government has started to make some rules. Now it's a matter of practical implementation for some of the farmers on how to live within these rules and realize it. And there will be challenges along the way, but it's an exciting income stream. And it's a true thing. You can't absorb carbon in so many things, but one of the simplest ways, obviously, trees and vegetation. So it kind of makes sense.
Stephen, I know, Christopher, you've got your hand up. I'm not going to, I'll come back in just 1 second, because we are at that point where we're at time, and I just want to, there are some that need to go. I just want to really, from myself, the Symphony 7 team, and, all the people who are here and will be watching later, thank you so much for your time, your effort, your thoughts, and the ability to really drive and take the questions. I'll come back to Christopher. I'll do a quick wrap up and then pass back. So we'll wrap up at this point because we do want to be able to let people go and get about their things. And I am actually one of those people that has to go pick up their child from 2 weeks away at camp. They're arriving. So I just again, thank you so much. Really appreciate it. The recording will be available. Usually Maurice is pretty quick, though he's in Bali, so it might be we're not going to expect it immediately like the usual process. And we're hopefully that others who listen to it and want to participate can also throw some questions your way, and we can do that through Anthony and Maurice if you're comfortable with that, Stephen.
Sure.
Thanks for
thank you so much,
Vlad. And I echo the thanks, Stephan. Really awesome. It's amazing to see these cool things going on and to learn firsthand from people like you. I will say anyone who needs to leave right now, please do so. Stephan, are you happy to stay for a few more minutes if people have questions?
Sure. I can stay, and I think maybe the one thing I would say, I mean, I obviously don't work for Incitec Pivot anymore or represent them, but I think their climate report is an excellent piece of work, by the way. So it's a very high quality corporate company in that respect. So if we have a read of that, I think there's a lot of process, lots of very, very good things in that. So and I basically hope that I can inspire some ideas, because what happens is we can apply through so many things, and there's so many things we can do in order to improve things along the way. And they can be small sometimes, but when they all add up, all of a sudden things start to change significantly. That's the exciting bit.
Wow, that's what a way to finish that conversation. Thank you, Stephen. That is exactly inspiring, and I'm sure that many here are, that would echo the sentiments for sure, especially when they are in their corporate and in their personal life as well. Thank you so much. Please feel free to continue. Please don't stop the conversation. We've definitely got Christopher had a question. I just have to apologize. I need to be one of those that does drop out at this time.
All good, Vlad.